Welcome to PyOhio. This is Mike Pirnat. He'll be talking about using Python to get out the vote.
Awesome, thank you. Hi, so like he said, my name is Mike Pirnat. I'm an advisory engineer at American Greetings. And in my spare time, I like to try to use Python for the forces of good. So a little bit of background. So my wife is really active in the PTA and with a lot of school issues and school groups. And one evening, I found her at her computer, toiling away, swearing at some spreadsheets. And I said, hey, what's going on? How can I help you? Like, is there anything I can do to make your life easier? And she explained that she'd been enlisted by the school levy committee to build the contact lists that the levy committee was going to be using for driving mailing lists, door-to-door, literature drop, phone calls on a per school basis. And what she was having with numbers and Excel was just not sufficient for her. And I said, hey, hold on, calm down. You know what I do, right? Like, I parse data, I model data, I stick it in a database, I pull it out of a database in different ways than it went in. Like, I got this. So, silly me, I got suckered into helping out with the levy effort this spring. And for those of you who don't know, Ohio's school funding system is really messed up and has been unconstitutional for like 20 years, but we still got to fund it somehow. So what a lot of times we need to do is to try to pass a levy so that homeowners will contribute to the school funding, because not all the money can come from the state, especially when the state keeps cutting away at it. Anyway, regardless of politics and how you feel about taxes, I feel like good about supporting my daughter who's in school and about supporting the school, so this was a no-brainer for me to help out. And that's all I'm going to talk about politics, no more politics. So the objectives for what we needed to do. We wanted to manage the committee's outreach to voters. So that's a mailing list, a door-to-door lit drop list, call lists broken out for each school. And a really important thing was to minimize both wasted contacts and redundant contacts. So on a wasted contact in this kind of domain is like a household that doesn't have any registered voters there. Like, don't call them, don't send stuff to their door. Like, you're going to waste your money on that and your time. Redundancy. So the way that the levy committee likes to do the call lists, they break it out by school. So each school has its own PTA, and that PTA contacts all the parents who have kids at that school. And if you have kids at one school, that's fine. But if you have kids at like 3 different schools, like one's in elementary and one's in middle school and one's in the high school, you're going to get multiple phone calls all selling you on the idea of making sure you go out and vote. And that ends up annoying people rather than supporting your cause. So we wanted to deduplicate that stuff. And that was something they weren't able to do in the past. And they had some consulting agency involved in the past. It was like $15,000 to do all this slicing and dicing. It's like, we can do that in Python for free. It's going to be great. So we need some data to slice and dice. So the Ohio Board of Elections actually makes lists of registered voters available for download for free in CSV files. You have to know which county you want. So go Google for your favorite county. I got mine from Cuyahoga County. And they also provide absentee ballot data, so you can know who has requested an absentee ballot, if it's been returned, and whether or not it's been challenged and for what reason. So that's pretty cool that it's out there. And then the levy committee was able to provide me with some Excel sheets that were based on things like the school directory data, where parents had signed a waiver to allow sharing that data for the school directory and other school-related purposes. A staff list for the school district, so we could understand who's affiliated with the district itself and might be affected by an increase or decrease in funding. The membership list for the early childhood PTA, so we can try to contact people who are about to have kids in the school system. And then a do not contact list that's mainly for people involved in the levy committee, so that my wife and I wouldn't have to get phone calls and because we're already on board, right? So we don't need that. So let's talk about some technologies. So Excel and numbers I basically use just to dump stuff out to CSV so I could munge it up in Python. Python, obviously, because it's awesome, and why not use Python for everything? In the standard library, CSV, datetime, and the regular expression module, RE, were all really critical friends, and SQLite was just the right thing to use for me. I didn't have to set up another server. I didn't have to like spin up a big database thing. I didn't have to make a root password. I can just use the standard library to say, I want to make a SQLite database, and here it's going to go. And for a one-person, small operation where there's only going to be a few tables, it's perfectly fine. You don't have to worry about contention and all those other fancy database scaling things. So I use SQLAlchemy to do my ORM stuff, so being able to take a model, fill it with data, and then stick it in the database, and then pull things out again. And Alembic is the tool of choice for managing your database migrations or making changes into the database so that your tables get created for you and things based on what you define in Python code in the model. And this was kind of fun for me because it's the first time I've actually spent a lot of serious time with SQLAlchemy and Alembic. So it was good to do some learning. So before we can really do anything and get too started on this road, we need to get a handle on what our data is and figure out how to model it and what we'll need. So there were all these CSV files that we received. So one's, the voter and the absentee ballot stuff is from the state, and these other things came in, first the student stuff, and then these other ones got added on later on. That's a lot of stuff. It's like 6 files, and there's all this data coming in weird ways, and the format's different in each of them. So there's a lot of stuff to keep track of, but if we step back, we can find some common elements that link things together. So these things we can pluck out and start to look at that and represent a physical location. So in this case, a household has an address. It knows about its precinct and ward that it's in. We might know the parent names involved with it from the student data, phone number, and then the indication of whether you're part of the staff, the PTA, or on the do not contact. Those can be just Boolean flags that we set based on whether you appear in one of those 3 CSV files. We also want to know about students. So we want to know which households have students, so we can pluck out name in the school and form that into a student. And we also want to understand voters that are going to be present in a household, and also want to know about their voting behavior and the status of their absentee ballot. So we can pluck those things out from the voter CSV file that we got and from the absentee ballot stuff. And now we have a voter that has a name and a party, and whether it's an active or inactive or provisional voter. I kept the Board of Elections voter ID around because it makes some things easier for me later on when I'm doing some joins and analysis and stuff. And it's a good idea to keep track of that absentee thing because we're going to need to know about that. And then we also want to know about a voter's ballot history. And we'll talk a little bit more about how that data is structured. But basically, we want to make sure that we get the type of the ballot, the type of the election, whether it was like a primary election, a special election, or a general election, and the date that it was cast. And once we have all those things, we've got all these nice entities that we can relate to one another. So a household can have 0 or more students. It can have 0 or more voters. And those voters can have 0 or more ballots. I had originally at one point tried extracting schools and elections themselves into separate tables that were related to the student and to the ballot. And it made the joins really, really cumbersome. So this is a case where I denormalize some stuff back together, maybe not super ideal. Like your DBAs might hate you for doing that, but like whatever. I've got the school name in a bunch of records. Oh darn! Like it's not going to hurt me. It just makes the join situation a lot easier. I want to touch really, really briefly on how I structured the project, and we'll dive into what these contents of these files actually are in a little bit. But so I had a directory that's my main. Here's all my code for the levy database, a directory where the stuff about Alembic goes, a directory for all the data that I'm going to import from those CSVs, and then a Python package inside there that I can import things out of. And so there's a module that knows about how to connect to the database, a module that knows, it's actually a script that I can just run to ingest all of that data and stick it in the database, the models.py file where all of those models are going to be defined, and then just a pile of scripts for various reports that I wanted to make. So remember that rough sketch we had just put together with all of our model entities? We need to translate that into SQLAlchemy model classes. So in our models.py file, we'll first import the things that we need to define the attributes of our models. So column, integer, string, Boolean, date, foreign key. Column is one of the things that we'll actually define in the model, and then integer, string, Boolean, date, and foreign key are types of columns that we'll put together in there. If you've ever used Django, this is probably real familiar looking. It's very similar philosophically. We want to make sure that we can relate these models to one another. So we want to make sure we import relationship and backref, which we'll talk about in a little bit. And then there's this magic thing called declarative base that lets us create a base class for our model to inherit from. And that will give us the ability to set up our model classes in a very declarative, easy to define way. It's very easy to understand, very easy to read. And so everything will inherit from this base class. So here's a household. And I'm one of those weird people who likes plural names in my database tables. So I can say select from households where blah, 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 which some DBAs like and some DBAs hate. You can do that with that underscore table name to override what table name gets created in the database. And I set an ID, which is a special integer that is, it's got that primary key true on it. So that will be our auto-incrementing primary key for the table. And we see it inherits from that base class. Got a whole bunch of attributes here, different columns. So some things are strings, some things are integers. There's a couple Booleans for do not contact, whether you're in the PTA or not, whether you're considered staff or not. And then there are these crazy relationship things. So we needed to define the relationships between households and students and households and voters. And we do that with this relationship indicator. So in this case, these are one-to-manys. And what we do is we specify the name of the related class. So in this case, student or voter. And we can say when we have these relationships and when we're exploring those relationships, what order do we want the related records to be in? And in this case, I'm just setting them by the ID of the student and the ID of the voter so that you'll get them in the order that they were inserted into the database. And then this thing called backref defines the name of the reference that's going to get injected or created on the related object. So when we have a student is going to get this thing called household, because we called it household here. It's going to get that on there, even though we're not going to define household itself on that related class. Make sense? It's kind of a weird thing to wrap your head around at first, and we're going to need to establish the other side of that relationship in a second. And then there's this parameter called cascade, and what that does is control the behavior of the ORM when one of these household records gets removed. So if we delete a record in household, we want to delete any related students and voters and cascade that operation to those so that we don't have referential integrity problems. So here's a voter. It has a table name and an ID just like household. It has all the things that we talked about earlier, the Board of Elections voter ID, last name, first name, data that comes out of that voter CSV file. Kept around birth year and party so we could do some analysis later if we felt like it. And then the stuff about whether an absentee ballot was requested, when it was returned, and was it challenged. And it's actually a string. It's the reason that the ballot was challenged. Which is kind of goofy, but Ohio and elections is weird, right? So to complete that relationship between voter and household, we need to include a foreign key with the household ID here. And we also need to use the table name, not the model name. So we say households.id in that foreign key. So the household ID is an integer column, and it's a foreign key that goes back to households, so that we've got the referential integrity. And this also helps us so that we can do all of our fun joins and stuff. And we have another relationship we define here out to the ballots that a voter might have cast. And so a ballot looks pretty straightforward. It has a table name. It has a primary key. It has a few things about it. It's got a voter ID reference as well. And student, it looks really, really similar. All right, so now we need to create the database, now that we've whooshed through all of this data modeling exercise. So the first thing we do is we tell Alembic, hey, Alembic, go init yourself in a directory called Alembic. And it will go and make a directory called Alembic, and it will drop a thing called readme, which is about what's in there, tells you how to use it and stuff, an env.py, a template for making the migration scripts, that's that Mako template, and a directory for storing versions, and then an alembic.ini file for configuration about how Alembic is going to use your database. So we need to edit a couple of things. We need to edit that env.py, and we need to edit the alembic.ini. So in alembic.ini, all we have to do is say, where's our database going to be? So we use that awesome how is that, 4 slashes URL, the SQLAlchemy : lots of slashes, and the full path out to the database. And then in the env.py, in the Alembic directory, we need to wire Alembic up to know where our models are so that it can use our model classes to be able to create and modify the database tables. So we import base and in there and set the target metadata to the metadata property of the base class. So it's a little bit of boilerplate, just stamp that down, don't worry about it, move on, everybody's happy. So then to create a revision script or a change set that can be run against your database, you tell Alembic revision -m, and you give it a message, just like you're doing a commit message in like Git or something, and tell it what you're doing to describe your change. In this case, I did all the data modeling up front, so we're just going to have one change set that knows how to create the model. But in actuality, as I was building this, I had a whole bunch of them because I kept adding new CSVs over time. And my wife would say, oh, now we've got this thing about PTA. You need to keep track of that. So you guys get the nice distilled version of it. Okay, so we say alembic revision -m, create model. We run that, and it creates in the Alembic versions directory a file with a hash on the front of it, just like a git revision, some random garbledy-gook, underscore the name of your or the description of your change set. So since I said create model, we get a thing that says hash blah 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 create model. If I had said add Smurfs, it would be hash blah 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 add Smurfs. And then to actually effect those changes in the database, you can upgrade to a specific hash. So you can apply one at a time in whatever order you want, or you can just say Alembic upgrade head, and it will do everything up to the latest revision that you've created. And the revisions in the alembic.py files or in the revision files that you make are basically a set of scripts that know how to alter tables or create tables or whatever to both advance into that revision and then roll back from that revision. So if you had to undo a change, the revision file that you get, that script knows how to undo that change as well. All right, so now we've got a database and it's got tables. We're very excited. Let's put some data in them. So let's ingest some data. So I wrote a script to just ingest the data because I liked blowing away the database and periodically refreshing it. Let's do all the things. So basically has a bunch of functions in it that ingest different data, and we run it in this kind of order. So the voter data is the first stuff we're going to process, then the student directory, then the staff, the PTA, and the do not contact data. Well, in order to do this, to make the script at all interesting, it's going to need to connect to the database. Originally, I had all of this connection setup stuff in each of the separate scripts that I was running to initialize the database, and then in all the reports I was making. And after about 4 of them, I got frustrated by copying and pasting that a lot. So I ended up rolling that all up and pulling it out into a separate module. So I have this db.py that I mentioned earlier. And what this does is really just reduces the friction for me. So we need to grab some stuff out of SQLAlchemy to know how to set up that SQLAlchemy connection to the database. And I had a module that I apparently failed to make it onto my slide that has some configuration stuff for me, like where the file is and some settings about the database. But basically what you do is you spin up a session class using this session maker factory function, and then spin up an instance of the engine. You tell it where it's going to connect to, where the file is, where the database file is, and then any settings that you want. So the echo will echo stuff out to standard out. So you'll see all of the select this, insert that, update table, create table, whatever. Alter table, like all that stuff, you'll get a huge outpouring of it. And that's nice when you're first starting out, but maybe not nice when you're running these scripts all the time and you're querying like thousands of rows and stuff. So once you've got an engine and the session class, you bind the engine onto the session class and then instantiate the session. So you end up with this instance of a session to the database. And the session is the thing that we're actually going to use to do all of our database queries and all of our database work. So having these out at module level global means anybody who imports this module or imports like session and engine out of it can talk to the database and do stuff, and it's just there for you. So there in our ingest_data.py script, all we have to do is just import those things, and we're off to the races. The database is there, the connection's there, we can start using it. So first thing we need to do is we got to read some CSV and parse that data and get data out of it. I'm going to show sort of a high-level example because every script that does this and every place that we do this, it pretty much looks the same. So we need to import the CSV module. We need to open the CSV file, and I really like Python's new style with syntax. It's pretty sweet. That makes sure that outside that block, when that block gets done, the file's going to be closed, everything's going to be cleaned up and nice and tidy. That's the context manager, I think is what it's called. It's pretty cool magic. And you can write your own, they're really neat. So good thing to check out later. But nice and easy, we open our file as F, and then we feed F to a CSV reader. We just spin up that reader. And the reader is just an iterable thing, and you can iterate over it. So the first thing I do is grab the header row, because I don't want to process the header row in the same way that I process every row that comes after it. Yeah?
I had a comment.
Yeah.
There is a CSV dict reader class that will pick up that header row.
Oh, nice.
And allow you to reference your fields
Okay.
using the dictionary.
Yeah, so the comment was for posterity that there's a CSV dict reader class that will pick up the header and build lists of dictionaries as you read it, or an interval of dictionaries. Yeah, I have had poor luck with that back in Python 2 land, like in the dim dark ages, and so I've become allergic to it for some reason. Maybe it works better now, but that's definitely a thing to explore and would be maybe worth looking at going forward. I actually do need stuff out of that header row specifically as well, though, and you'll see that in a second. But anyway, so we can grab that header row with reader next, and then just start processing rows. We can walk through it for each row in our reader, and we can pluck out, here's the value, and here's where it is in the row, and here's the value, and here's where it is in the row. And then we need to jam that data into SQLAlchemy. So here we are, we're still in this reader loop, and we have some set of, oh, yay, a slide I didn't update, cool. We want to start building model objects, and we can feed the appropriate values that we plucked out of the CSV, feed them into the model object. So in this case, like this would be the household or student or voter, those classes that we had. And we tell the session, hey, we want to add this object. And then once we're ready to put it in the database, we need to explicitly say session commit so that it flushes that out to the database. So ballot data. We told you we were going to talk about ballot data because ballot data is kind of funky. This is where needing to know about the header is important. So the way that Ohio gives us this data, the election type and the date are encoded together as the title of that row in the header. So G_11_04_2014 is a general election from 11/24/2014. S_ something is a special election. P_5- 2006-2014, they're not even consistent, is a primary. And I should have been filing through those, great. So the ballot type that gets voted in those elections, whether it was, yes, you showed up because it was a general one, or maybe it was a Democrat or Republican or Green or Libertarian because it was a primary, or no thing at all because you didn't even vote, shows up as like a Y, or like this is, I didn't even vote at all, and this is maybe I voted Democratic or something, It's the type of ballot you were issued when you got polled. And it's kind of gross, so we need to break that stuff up and record it appropriately. So while we're getting the ballot data, we're going to use a little bit of zip magic, and we're going to extract, in the most recent data, it was columns 18 to 65 of this spreadsheet, or like you get like 10 years of election data. So we extract those headers from the header row, those titles, and combine them with the values for each individual voter using this zip magic. And now for each election and each election and what ballot you used, we've got a nice little tuple that we can walk through and use here. So if there was no ballot type because you didn't vote, let's just ignore it. We don't need to create a record for that. We want to make sure we go munge up that title and turn it into something meaningful. So we want to understand whether it was a general or a special or a primary election and the date. And so we can write a little function to go parse the election title and turn it into these things. So we got to normalize the underscores and dashes and chop them up into things. Then we can build a date out of that. And fun bug that I forgot about is date time only once, numbers and not strings. So you got to remember to int those things. And then you can return them back. And then we've got nice stuff you can jam into a ballot. So here's our ballot class. We put our ballot type, the election date, and the voter ID, the Board of Elections voter ID in there. Add it to the session, commit it, boom, it's in the database, hooray. Repeat for like 24,000 people. Well, so we talked really briefly there about how Ohio has messed up data formats. Well, so does everybody else. So we've got to normalize and link our data together. We need something that's common between students and households and voters. And we decided that address was really where that was at. So a household has an address, and a student thing had an address, and a voter has an address. These values can be equivalent, and you can do that, but they're not guaranteed to be equal values. So here's a concocted example of what this actually looks like. In the Board of Elections data, you get stuff like house number, the prefix for the direction, whether it's a north, south, east, or west, whatever. You get the street with the street super abbreviated. You get apartment super abbreviated and with very few extraneous characters, and zip code. Whereas the school directory from the school district had, well, here's mailing street, and even it's not necessarily consistent. So like apartments, some have hyphens, some have numbers, some have multiple spaces, some say apt, some say apartment, some don't. Huge mess. And maybe you get a zip code. It's basically whatever some parent filled out on a piece of paper and somebody keyed in manually. So we have to normalize this to make things line up. So let's write a little function to do this. So first, let's uppercase whatever address we feed in. Strip out anything that's non-numeric, and not a space. So let's get rid of all the octothorpes and dashes and underscores and slashes and whatever else we might find, periods, right? Condense all the white space. So anywhere we've got multiple spaces in a row because somebody keyed it weird or something, let's condense that to a single space. And then start replacing things. So we've got all of these, some streets are abbreviated and some are not. So there's multiple ways to do things like avenue that are acceptable. We can build a list of regular expressions for that, which we'll look at in a second. And we can walk through all that and make sure that we sanitize all that data, get it how we want it to be. And then I ran into issues where I accidentally added an extra space in all of this shenaniganry. So let's strip that out again, just in case. And make sure we do some, strip out the stuff around the edges because still things are a little goofy. Then we just specify our list of regular expressions. The US Postal Service actually has a document you can get online that lists every single allowable street suffix in the US and their abbreviations. And some of them have like 4 or 5 different acceptable long values, and like here's what we normalize it to for the USPS. So I just implemented what I needed for my locale in Westlake. But there's like lots of them. There's all kinds of trails and courts and stuff that you might have to worry about. Yeah, so some of them are represented here. Like Parkway, you can have Parkway, you can have PKY, you can have PKWY, right? It's kind of goofy, all those things. So let's turn it into the very barest thing that is most likely to match, and we'll do it on both sides. So once we've written that normalization function, we need to plug it in a bunch of places. So here's while we're ingesting voter data. We want to just join all the stuff that the Board of Elections gave us and run that through. So we've got like a good clean place to start with for households. We'll try to match an existing one maybe if we've got it. And then if we've got it, let's add the voter onto the household because there might be multiple voters, right? So like if it hits my wife first and we create a record, we want to also join me up to that existing household when it hits me later in the spreadsheet or in the CSV file. Otherwise, if you don't have a match, we need to make sure we create a new one there. So we go and do that stuff that we showed earlier. We also need to do this when we're ingesting the student data. So whatever stuff we got from the student CSV, we need to normalize that as well. And if we get a hit on household, we need to make sure that we glue on parent names and phone number and stuff that we get out of that CSV file. Otherwise, create a new household. And then for staff and early childhood PTA and do not contact data, we need to do the same kind of normalization and lookup. In this case, if someone is like early childhood PTA, staff, or do not contact, but they don't have a household, we just want to skip it because that means they are maybe part of the community but don't live in Westlake and therefore cannot vote in the election. So we don't really care about making households for them. All right, cool. So got some stuff. We maybe need to do some updates along the way. Here's how, like a real quick look at how updating data works in SQLAlchemy. So you can use, if you've got a single model object, so I've got one voter, I can say, hey, voter requested an absentee ballot equals true. So voter absentee ballot requested true. That just updates the attribute in the instance of that class. And then session.commit will flush that update to the database. And SQLAlchemy is pretty smart about knowing what things have changed and knows only to do the things that have changed in your model. You can also update many rows without a model object. And this was really helpful for me when I was periodically getting updates of the absentee ballot data, because every week you get a new update that says, oh, here's all the additional people that have requested an absentee ballot or have returned them. So we were interested in tracking like what the returns were like on absentee ballots. And the first thing I do is just blow away all of the status and then just re-import the absentee data, and life was pretty happy. But so you do that with session.query on whatever the model object is, so in this case a voter, and you use this update method on that. And you can pass it a dictionary of the things that you want to update and the values you want to set them to. So you actually have to use a string there to say, to specify the name of the attribute. So absentee ballot requested, required, or challenged, and set them to none, and that will null them out in the database. All right, so now we've got a database loaded up with stuff. It's time to extract some things and make some reports. So basically, I talked about earlier that pile of scripts that I had to do all these reports, pile of scripts, right? And they all basically all look like this. They have something that more or less says get data, and something that says write the CSV, a main function that says, hey, actually go get the data and then feed it to write CSV, and a little under name equal main gizmo, so that when I run this from the command line, it'll just fire it off and run the whole thing and fire off my main function. So we need to query some stuff with SQLAlchemy. Here's the very quick crash course. We can do lots of things. So we can get a single object. So I can say, hey, session, go query for some kind of model object and give me the first one. Or, hey, go get me all of them with .all. Or I can have a limit and an offset using Python slicing syntax. So I can say, hey, go get me everything from row 42 up to row, or excuse me, get me 2,112 rows starting at row 42. So that gets you around having to specify in SQL all that grody, limit this, row num that, whatever. Oh, this is much easier. Hooray, slicing. We can use filtering operations to find, say, the first model object where some attribute it has some value. So this is your where attribute equal value in SQL. And we can stack these things together, chain them together. You can do filtering. You can do group by to group records together. You can do order by. All these things are the same sort of things you're used to doing in SQL. You can do in SQLAlchemy in a nice Pythonic style. Let's look at something that's more specific to the domain we're talking about. So here's querying for a household. We're going to filter by address to find a household with that address, and we're going to get the first one because we only want one. Or a more complex example is going out to, what are we doing? We're getting voters joined with households. We're filtering where it's somebody who's allowing a contact. So we're saying do not contact equals none. In a certain set of voter statuses, so we only get people who are active and provisional. Grouping by the household ID because I don't want all the voters, I just want the households. Ordering it in a certain way and setting some options on it. This contains eager is pretty neat. That makes sure that the related objects, so like in this case, the household that's attached to a voter is going to be fetched and constructed at query time using the data from that query. Otherwise, it would do additional queries later. And that is helpful. We'll see that in a minute. So then we know how to get data out. We know how to read data. We know how to put data in the database. We know how to get some data out. Now we have to write CSVs. And this is pretty straightforward. It looks pretty much the same regardless of how we do it. So we have our little write CSV. You can pass it some objects. Go ahead and open that report writably this time and use a CSV writer. Build up a header row with what our new headers are going to be, and then write that row out using the write row method on the writer. And then we want to loop over our model objects, build up a row of data, and then write it out. So we say write it out, write row, and then we're done. Yay. So let's get into some specific reports. This is where the fun part is. But before we do that, let's think a little bit about targeting strategies, because the levy committee is operating on this shoestring budget, and it's hard for them to get a lot of funding. Like I said, we're saving all this money in consulting fees, but it costs a lot of money to print and mail things, right? So we want to make sure that we're only printing and mailing to what we have budget to print and mail to. So we want to think about some strategies for limiting the number of voters or the number of households we're going to contact. So active voters we defined as registered voters who are either flagged as active or provisional because that was whatever status they'd picked up when they last voted. Recent voters. So this was a special election or in May this year. It was the only issue on the ballot. We really only cared about people who had voted in off elections, so non-presidential, non-general elections, to consider them as somebody who would actually go to the polls and care about this issue. And it's also interesting to think about voters that are affiliated in some way with the school district. So they either have kids enrolled in a school, they're parents that are in the early childhood PTA, or they are staff in the school district. Like we said, these counts have a cost associated with them. So there's 23,000 some voters in Westlake and 12,000, almost 13,000 households. But not everybody has active voters. Not everyone in there is a recent voter. And then only a small slice of that is actually affiliated with the school. So only 3,700 houses or 3,700 voters have kids in school. And an interesting thing here, remember this number 4,500. 4,500 is halfway between this 1847 and 7238 households, just like a ballpark halfway. It feels like our sweet spot of how many households we're going to mail to should maybe be somewhere in between those. So first report we put together was the mailing list. So these are households with registered active voters who voted in either May 2014 or who voted in November 2014 and had kids in school. So November 2014 was also a school levy on the ballot. And we want to make sure that these are people who aren't flagged for do not call. So we want to go spin up this query for voters joined with ballots, joined with households, optionally outer joined with students, in the allowed statuses of active and provisional, where do not contact is none. And here's like a little kind of gross construction here where we're saying that either the ballot election date is that first date, the 5th of or 6th of May 2014, or it's this November 2014 where both the election date is this date and there's a student with some last name. So that was just sort of our way of saying, like, yes, they actually have a student. It's not like a none from that outer join. We want to group this by the household ID because we really are only caring about mailing to households, and order them by last name and then first name so that we can have a nice sane sorting so we can validate our data and make sure we're hitting the right people. And this contains eager, like I mentioned, as this cool trick that makes sure that you actually get that data preserved from the initial query and you don't have to keep re-querying. So if I said, I want this voter's household, it's not going to go and do another select to get it. And we want all the records. And that actually gives us 4,279 households to mail to, which is pretty close to that sweet spot we thought, that estimate, and it's within the budget. So they thought it might be about 4,000. So our initial hits of like 7 and 11,000 were like, no, we can't afford that at all. But like they budgeted for about 4,500, and here we came in pretty close to that. So that seems about right. So yay, validation. Another thing that was challenging and fun was the idea of this call list, where we had a list for each school, and we wanted all these criteria about the households. We only want to call people who have phone numbers. We don't want to call people who requested an absentee ballot because they're already motivated, they're invested, they've already requested that. And we want to deduplicate so that if we call an elementary school family, we don't also recall them when it's the high school kid or the junior high kid. So in this case, what I did is I made a little wrapper function to go and abstract the idea of making this list and writing a CSV, and it's going to remember the households that it's seen along the way. So we go and query for students in that school or households that have students in that school. And when we're writing the CSV out, for each for each household that we see, we mark that off in a dictionary so that we can do a fast lookup on it later. And then our main function declares this empty dictionary that we can feed in, that will cache all of the things it's seen so far. And then we can walk through and start seeing, making these various lists. Names have been changed to protect the innocent, so these are my favorite fictional schools. You may recognize a couple of them. Another report that was interesting was about unreturned absentee ballots. So these are people who requested a ballot but haven't returned it yet. And we might want to harass them and be like, hey, you requested an absentee ballot. You better get that in because it's important. We need them. Kids need the money. Well, think of the children, right? So in this case, we filter where the absentee ballot requested is not none, but the absentee ballot returned field is none. And we would do that periodically throughout the course of the month leading up. Yeah, so this is our last fun thing my wife and I came up with. This is not something that was requested from the levy committee, but it's kind of entertaining. So the shame list are registered active voters who are affiliated with the school district in some way. They've got a kid in school, their staff, or whatever, but they have not voted in these off elections. These are people who should feel bad about themselves because they're not holding up their end of citizenship. However you vote, it's important to get out and vote. You should vote. Voting is good. People died for you to vote. You should vote. So what we do here is we got this kind of gross-looking query. So we're joining voters on households, again, outer joining to students. This gets us all the people who might be affiliated possibly with the PTA or our staff. ordering them in a reasonable way, and again doing the contains eager trick. And then I originally had written this as more of a for loop with checking a thing and setting a status. And you can do all of this with any and a couple of list comprehensions, which is kind of fun. So here we're saying, give us all the voters. If there are not any ballots that are between this date and that date that we considered to be recent elections. And the reason for doing it this way instead of in the query is that either way, the query sucks when you're trying to exclude the things in the range. So I would prefer to get data back from the database first and see that that happened rather than waiting half an hour to find out I had done something bad. So here, I get the data quickly, and then I have to go and query the ballot situation for each voter, which takes a while to chug through all of those 24,000 selects, but it's not terrible. And this is like, we ran this as like the last thing in the list, so we get all our other data first. So then there's this list comprehension that knows how to check if give me all the ballots that are in our voters' ballots if it's between this date. So we can know about the shame list. And unfortunately, like the number of people in this list is a lot higher than I would like. It's pretty bad. It's probably like 3/4 of people like just aren't voting in these off elections. It's very depressing. So yeah, get out and vote. So some other reports that we made that we're not going to talk about today. Made a report that will figure out the door-to-door list for doing literature drop. That one excluded households that had requested an absentee ballot because they're already engaged. We don't need to tell them about it. They know this is like the one issue on the ballot, so they're aware of it because they requested that absentee ballot. We made a list of school-affiliated absentee ballot requesters. We inverted the shame list and made a praise list of people we could feel good about. So yay! Like, these are good people. We should thank them for being good. We're running pretty close. Oh, yes. Yeah. No, my wife and I are really good about getting to elections and voting and stuff, so good. Voting's good. And then various scripts that would do counts and some data analysis just to give numbers to people to be able to explore and understand the volumes of data and what was involved. All right, so getting into the home stretch now. Some thoughts to leave you with. The next steps that I want to do with this, I like to do some post-election analysis. Actually, the data just dropped from the Board of Elections last week, and I haven't had time to mess with it yet because I was getting all my slides together. It's the danger of going on vacation in July right before a conference is you get all vacation-y and not a whole lot of slidey going on. But I want to do some post-election analysis and understand what were the absentee ballot returns like, what was the voter turnout like for people who were affiliated with the schools in some way, how did the party affiliation break down on voting? Like, do we have a lot of Democrats voting? Do we have a lot of Republicans voting? Like, maybe Democrats didn't turn out, and that's why the school levy didn't pass or something. I also want to refactor and repackage some of this for reuse. There was a lot of stuff in those queries that you saw that was repeated, a lot of commonality. Because that query hasn't been run yet until you call .all or .first or something on it, you can have that object with some state on it, and you can probably pass it to something that knows how to decorate it with more stuff, and it has modified the state of that object. And then eventually, when you call .any when you call .all or .first on it, it will run the query with all that other stuff that you decorated onto it. I kind of like to do that so that things like the voter status or the absentee thing could be more reusable. And apparently, I'm on the hook to help out with something else coming up in the fall, so it would be good to have that. So a little bit of advice and some thoughts. So like we talked about at the beginning, I was trying to model too much stuff. I had schools and elections as separate things. Only model what you need to model. Your life will be simpler. There's a whole lot of other stuff I could have modeled like the Board of Elections has tons of data that things like 80 or 90 columns wide and has like your congressional district. I don't need you don't need it. So don't model what you don't need to model. Code for repeatability. Everything that I wrote in a way where I could just arbitrarily delete the database at any time, recreate it, rerun everything, and it would just be a couple of commands. In fact, I even wrote a shell script that would run all the reports so I could, in one line, go update data, drop things, do stuff, run reports, and drop it into Dropbox for my wife to get the data right away. Something that was really important when working with my wife as a client, and by extension the levy committee, is that a shared understanding of how you specify those queries is probably 90% of the work. Like, most of the work I did was trying to coax the requirements out of her in the right precise ways to get just the data that they wanted, because not everybody in the world likes to specify things in as exacting and precise detail as we might need or might want. And so plenty of times I had to go back to the drawing board with, no, it shouldn't be like that. Even though I told you it was like that, no, it's not like that. Like, okay, I'll figure it out. We'll work on it together. And like using the right vocabulary and establishing that shared vocabulary was really hard work, but valuable. So that's where you really need to focus with your customer or whoever you're working with on that. You should expect arbitrary changes on short notice. Like a lot of the scripts or new CSVs that I got were like, oh, surprise, now you have more requirements. Like, I'm sure nobody has that experience at work, right? It's just weird to have that at home too. And finally, use your powers for good. Like Python gives us all these amazing things. Like most of this was out of the box stuff that you get in the standard library, right? Use your powers for good. It's very satisfying to try to do something civic-minded, to do something that may benefit people, and also to not use your powers for evil. So with great Python powers, great responsibility. I'll leave you with a few links. I'll post the slides up on my blog in a little bit, hopefully this afternoon. If not, it'll probably be tomorrow. But you can go find, like, here's where I got my USPS data, my Board of Elections data, a pretty good ORM tutorial from the SQLAlchemy docs that was really beneficial for understanding how to work it and how to do the stuff with Alembic. If you need to get a hold of me or want to talk more about this, my blog, which I unfortunately seldom update anymore, but will soon, is out at mike.pirnat.com, or you can tweet me at mpirnat, and I love to Twitter. It's good, so like, be in touch if you want to be in touch. Otherwise, I think I ran over the question time, but we've got a couple minutes, so if anybody's got questions, I can try to address them. Oh, we do not have time for questions. Well, I'll tell you what, let's do, like, if you want to chat about it, we can chat about it in the hallway track after this, because hallway track, yay. All right.